If you're studying for the PTCB exam and the pharmacy math part has you feeling a little nervous, you have come to the right place. Today, we are going to crack the code on one of the biggest sections, concentration and strength. I want you to really let that sink in. By just mastering what we're about to cover in this explainer, you are setting yourself up to answer almost half of the entire math portion of the exam. That is a huge advantage. So, welcome to the PTCB Prep Guide. Our whole goal here is to make this stuff finally click for you. And trust me, concentration and strength, it isn't just another topic. It's the absolute bedrock of pharmacy math. You're going to see it pop up in dosage problems, compounding questions, IV calculations. It's literally everywhere. So if you can nail this, the rest of the math on the exam gets a whole lot easier. All right, so how do we tackle this giant topic? Well, the good news is it's not as scary as it sounds. It really all boils down to understanding just 3 key ways of looking at strength. Let's break them down. Here they are, the big 3. Percent strength, which we'll see is directly related to milligram per milliliter strength. And finally, ratio strength. The real secret here isn't just memorizing definitions. It's about seeing how they all connect and convert into one another. Once you see that pattern, the math starts to feel, intuitive. Let's start with the one you are absolutely going to see the most often. You could say this is your bread and butter for concentration questions on the PTCB. Okay, so at its core, percent strength is actually really simple. The word percent literally means per 100. So if you see a 5% solution, all that means is there are 5 grams of the drug for every 100 milliliters of the solution. That's it. It's just a relationship. Now, you might see these little letters next to the percent sign, W/V, W/W, and V/V. That's just weight in volume, weight in weight, or volume in volume. But listen, here's a pro tip for the exam. The one you really need to focus on is percent weight in volume, or W/V. That's always going to be grams per 100 milliliters. So how do we actually use this in a calculation? Let's take a 2% solution. Okay, so we know that means 2 grams per 100 milliliters. And we also know there are 1,000 milligrams in a gram, right? So 2 grams is the same as 2,000 milligrams. Now we have 2,000 milligrams per 100 milliliters. Do a little quick division, and we land on our final strength, 20 milligrams per milliliter. The logic is perfect. But let's be honest, doing all those steps on a timed exam is way too slow. So here is the shortcut, the one trick you absolutely have to know. To get from percent strength to mg per ml, you just multiply the percent by 10. That's it. A 2% solution, 2 times 10. That's 20 milligrams per ml. A 0.5% solution, 0.5 times 10. 5 milligrams per ml. This is a total game changer for your speed on the test. Okay, now that we've got a really solid handle on percent strength and that awesome shortcut, let's look at the other 2 formats you're definitely going to run into. Milligram per milliliter is probably the most direct and honestly the most useful way to express strength. It tells you exactly how much drug is packed into every single milliliter of that liquid. You'll see this all the time for things like injections and oral solutions because it makes calculating a very specific dose super straightforward. And then you've got ratio strength. This one looks a little different. You'll see it written as 1 to something, like 1 to 1,000. It's simple though. It just means there is 1 gram of the drug for every 1,000 milliliters of the total solution. This format pops up a lot when you get to compounding questions. And yeah, just like before, there are simple ways to flip between these formats. If you want to go from a ratio to a percent, you just divide 1 by that bigger number and then multiply by 100. And going the other way, from percent back to a ratio, it's pretty much just that whole process in reverse. You can definitely expect the PTCB to ask you to do this conversion. Okay, theory is great and all, but let's actually put this stuff into practice. Let's see how knowing these concepts makes real exam questions feel, well, almost easy. All right, here we go. This is a classic PTCB-style question. You're going to see this format over and over again. How many milligrams are in 30 milliliters of a 2% solution? Just take a second, think about that shortcut we just learned. You see how it works? It's so clean. Step 1, use the shortcut. That 2% instantly becomes 20 milligrams per ml. Step 2, just multiply that strength by the volume you actually have. So, 20 milligrams in each ml times 30 mLs, and bam, 600 milligrams. 2 simple steps, and you've got your answer. Let's try another one, a slightly different angle. The label tells you the total amount of drug and the total volume in the vial, and the question is just asking for the strength. The key here is realizing the question is giving you everything you need. You just take the total milligrams, which is 40, and you divide it by the total milliliters, which is 10. That gives you a strength of 4 milligrams per milliliter. Once you know what you're looking for, these questions are just guaranteed points. All right, we have covered a ton of ground, I know. So let's boil it all down into one super powerful summary slide that you can use for your last-minute review. This is it, your cheat sheet. This one slide has every single key formula and conversion we've talked about. I'm serious. Go ahead and take a screenshot of this right now. If you can memorize these 6 points, you are going to be in fantastic shape for any concentration question the PTCB can throw at you. And there you have it. You now have the formulas, you have the shortcuts, and you have the skills to totally master concentration and strength calculations. If this explainer helped you out, do me a favor and hit that subscribe and like button. And you are not going to want to miss our next one, where we tackle the single most powerful formula in all of pharmacy math, dilution calculations using C1V1 equals C2V2.